In this presentation, we will cover how to perform a hypothesis test for the difference of two means. Note that this presentation is not meant to replace your reading of section 7.3.2 in the textbook. While watching this presentation, it would be very helpful if you follow along in the corresponding portion of the textbook. Lastly, please note that you are responsible for reproducing all parts of this presentation on paper according to our course guidelines for formatting of written work, except for any portions that appear in italics or any slides within the presentation that are specifically identified as not requiring reproduction. We will use the example in section 7.3.2 as the basis for our hypothesis test. A data set called NC births represents a random sample of 150 cases of mothers and their newborns in North Carolina over a year. We are particularly interested in two variables from the data set, weight and smoke. The weight variable represents the weights of the newborns, and the smoke variable describes which mothers smoked during pregnancy. We would like to know, is there convincing evidence that newborns from mothers who smoke have a different average birth weight than newborns from mothers who don't smoke? We will use the North Carolina sample to try to answer this question. The smoking group includes 50 cases, and the non-smoking group contains 100 cases. Note that the table below contains summary statistics for the North Carolina sample. In addition, we were also provided with some histograms of newborn birth weights for infants whose mothers smoked, which is on the left, and for infants whose mothers did not smoke, on the right. We will now go through our familiar four-step process to conduct a hypothesis test to evaluate whether there is a relationship between a mother smoking and average newborn birth weight. So step one is our prepare step. First, we identify the parameter of interest, which in this case is the difference in average birth weights of newborns from mothers who don't smoke and of newborns from mothers who do smoke. By the way, the subscript N stands for non-smoking. Next, we list the hypotheses, which I have shown below on the slide, for the null and the alternate hypothesis in this case. The skeptical position, of course, would be that there is no difference in the birth weights, and that's why we have that the difference being 0 is the null hypothesis. Next, we identify the significance level. Since it was not stated in the problem, we always assume that the significance level is 5% unless stated otherwise. Next, we list the summary statistics for each of the samples as well as the respective sample sizes. I have gone ahead and gotten those from the summary statistics table that was a few slides back. And then the last thing we do for the prepare step is calculate the point estimate, which in this case is given by the difference of sample means and is approximately equal to 40 hundredths, or 4/10. Next, we consider the check step, in which we need to verify conditions necessary to model the difference in sample means using a t-distribution. We begin with the independence extended condition check. Note that because the data come from a random sample of mothers and their newborns in North Carolina over a year, which we then split into two distinctly different groups, the observations are independent, both within and between the two groups. Next, we perform our normality condition check. Since both sample sizes are greater than 30, we'll use the corresponding rule of thumb, which requires us to look for particularly extreme outliers. However, from the data histograms that we were provided, we saw that there were no particularly extreme outliers, and therefore this condition is met. Since both conditions are satisfied, the difference in sample means may be modeled using a t-distribution. So next we move on to the calculate step. Since the conditions held, we start by computing the standard error. I've shown the formula on the screen as to what we get as a value for that. In this case, we get 26 hundredths for the standard error. Next, we compute the test statistic t, capital T. Notice I've written the formula on the slide, and I've also calculated the value as being approximately 1 in 54 hundredths. The next thing that we need to do is to identify the p-value, which will require us to start drawing a null distribution sketch. So I've gone ahead and started doing that on this next slide. The first thing I need to do is put the null value, which is 0, in the middle. Then I go upwards by units of standard error until I get 4 standard errors above, and then I go downward 4 standard errors until I've completely scaled the difference of sample means axis. Notice that in this case I also have to include the units, which are pounds, because that's what the units are that we are measuring the weights of the newborns in. Next, I'm going to go ahead on my sketch and include vertical lines going through plus and minus capital T, capital absolute value of T, excuse me, and then I labeled those values on the sketch. And then the last thing I'm going to do for the sketch at this point is shade the tail areas corresponding to the p-value. Now that we've drawn the vast majority of what we need for our null distribution sketch, the next thing we need to do is to find the value for the shaded areas under the curve that we just shaded on that sketch. That is, we need to find the capital P or probability value. We'll use our guru to do so. So within our guru, we left-click on Analytics, left-click on Analysis, move down to the Mean Inference drop-down menu item, and left-click on 1 and 2 population. Within the dialog box, I'm simply going to enter in the information that we were given from our sample of the women that we collected from North Carolina. So I start with non-smoker as my label for the first set of mothers. Sample mean birth weights was 7 1/1800 pounds. Sample standard deviation was 1 60/100 pounds. Sample size was 100. Okay, next I come over to population 2. My label here is going to be smokers. That designates mothers who were smokers. Sample mean birth weight of their newborns was 6 78/100 pounds. Sample standard deviation was 1 43/100 pounds, and the sample size was 50. Next, I click the population 1-2 tab because we're doing a difference of populations. I'm going to clear out the confidence level because we're not doing a confidence interval. I come over to test of hypothesis. Significance level was 5%, so I leave that value as is. I select the alternative hypothesis statement symbol, which was not equal. I type in 0 for the pounds. I click the T statistic method for the method of testing that we're doing, and I then go ahead and click the preview. Looking down at the table below, I can see that my p-value is it is 1,238 ten-thousandths approximately. Now, at the same time, I also get other information given to me. I have the point estimate, which should match what you calculated already. I have the standard error. That should also match the calculated standard error that you have on your paper, and also the capital T value is provided, and again that should be very close to or match the capital T value that you calculated earlier. Now that I've demonstrated how to use our guru to find the P or probability value, you would need to write down on paper the following. So on the slide I've now shown what you would need to write down as what you did within our guru to find the P or probability value. The last thing I want to remind you of is something that I said during the Arguru demonstration. You should take a moment to check the point estimate, the standard error, and the test statistic values that you previously calculated against what was provided by Arguru. It's just a good idea to double check those values. Before we move on in completing the calculate step, I need to make a quick comment. The p-value that we found in this video differs slightly from the one found in the textbook for this problem. The reason why is because the textbook uses an approximation for the degrees of freedom, which we bypassed by using our guru. Note that you are expected to use the Arguru-based techniques that were shown in this video. Let's go ahead and complete our null distribution sketch at this point. Now that we have the p-value, we go back to our sketch and identify or label each tail with half of the P or probability value. We now move on to our fourth and final step, which is the conclude step. We're going to first of all evaluate the hypothesis test by comparing the P or probability value to alpha. So we do that by taking a look at the values that we had. We see that 1,238 ten-thousandths of our p-value is greater than the significance level of 500. Therefore, we fail to reject the null hypothesis. The last thing we need to do is provide a conclusion in the context of the problem. In this case, our conclusion is, therefore, there is insufficient evidence to say there is a difference in average birth weight of newborns from North Carolina mothers who did smoke during pregnancy and newborns from North Carolina mothers who did not smoke during pregnancy. Now, although I have completed our hypothesis test example, I do need to make a couple of comments about the results that we just saw. While we have used this relatively small data set as an example, larger data sets show that women who smoke tend to have smaller newborns. In other words, the hypothesis test that we just completed resulted in a type 2 error. In fact, there are people in the tobacco industry that actually had the audacity to tout the fact that women who smoke have smaller newborns as a benefit of smoking. Here's the quote. "It's true. The babies born from women who smoke are smaller, but they're just as healthy as the babies born from women who do not smoke. And some women would prefer having smaller babies." That was a quote from Joseph Coleman, Philip Morris's chairman of the board, on CBS's Face the Nation on January 3rd, 1971. Here's a fact check about that. The babies born from women who smoke are not actually as healthy as the babies from women who do not smoke. And that concludes this presentation.